Empirical formulae calculation here. 5.29 grams of element X combines with 1.84 grams of element Z. Calculate the empirical formula of this compound. And we've got some relative atomic masses here. Remember, empirical formula is the simplest ratio of one element to the other. And what we must know this formula. Moles equals mass divided by atomic mass. I'm just going to use the symbol AR for atomic mass. Okay, and we're going to write X here and we're going to write Y here because we need to do that calculation for both X and Y. Okay, we need to do moles equals mass over atomic mass for X, and moles equals mass over atomic mass for, sorry, Z isn't it, not Y, sorry, my mistake. We need to do it for Z as well. Okay, so 5.29 grams, we know that's the mass because it's got a unit after it. Grams is a unit for mass. So that's going to be the mass of X, 5.29, and we're going to divide that by the relative atomic mass here, which is 23 in this case. Chuck those into a calculator. We've got 5.29 divided by 23 equals, and that looks to me to be 0.23. 0.23, and we need to do exactly the same now for Z. So there's our mass of Z. We know it's a mass because it's got a unit after it, grams. 1.84 grams of Z. 1.84 grams divided by the atomic mass of Z, which is 16. 1.84. So let's put that in the calculator again. 1.84 divided by 16 equals. Okay, this time it's 0.115. 0.115. Now, with empirical formula calculations, after you've done this stage, I want you to ask yourself two or three pretty simple questions, okay? The first question I want you to ask yourself is, are these numbers the same? If these numbers are the same, then the ratio of X to Z would be 1 to 1, and therefore the formula, the empirical formula, would simply be XZ. So that's always the first question to ask yourself, are these numbers the same? Now, clearly here they are not the same. The next question I want you to ask yourself is, which number is bigger? Is X bigger or is Z bigger? And these are simple questions. They're not trick questions, I promise you. So in this case, X is bigger. X is bigger than Z. 0.23 is bigger than 0.115. That means in our final empirical formula that there's got to be more X than Z. So the number for X in our final answer has to be bigger than the number for Z. And the third and final question is, how many times bigger? What's the ratio? So that's the next thing we need to do. We need to figure out the ratio of X to Z. Okay, now the way you're going to figure out the ratio is you're going to take the big number, which you've decided is X, and divide it by the little number. So 0.23 divided by 0.115. Okay, my mental maths tells me that's 2 straight away. Okay, that therefore means we've got X2, and if because we're dividing by the little number is Z, the little number is going to be 1. Okay? So our ratio is X2, Z1. It's a 2 to 1 ratio. So our final number, therefore, our final formula is going to be, therefore, X2Y. The formula is not quite X2Y. I've done the same again. No, it's X2Z. I should get. It's not Y, it's Z, isn't it? X2Z. So let's just rewrite that completely. X2Z. This is the method you use for all empirical formula calculations, and there's more to follow in this booklet. All these questions on ayleshamhighchemistry.com.